That's you, mate, there. So we were getting a bit twitchy. Alvaro went off to the restroom a little while ago, and we were about to send out search parties, and this could have been like some horror movie, as we all headed down to the toilets. So I can just see white lights. So a good afternoon, good late afternoon or early evening to you all. I'm delighted to have been asked by Melanie to chair this panel as she went down her list of suitable candidates. But I'm delighted to chair it because I've been a user. So whether it was in the early 90s in the Balkans on a 256 kilobits per second link on Iridium or even on a VSAT, or providing a wide variety of both military and commercial satellite communications during 3 Afghan tours between 2002 and 2009, or indeed, about a decade or more ago, running the UKMOD Skynet program for 3 years. And I've now had about 10 years in industry. 7 of those with Viasat in the UK, setting up that company, and they've obviously gone on to buy Inmarsat, which was a bit of a shocker. And just over 3 years with NSSL Global. So we're a systems provider, service integrator, supporting a lot of defence customers, primarily maritime, and also airborne and land services, but also a major commercial maritime service provider as well. So some of the conversation from the earlier panel about seafarers being stuck at sea during COVID, needing greater access to welfare, a big resignation issue, and in the US case, and regrettably, obviously, some suicides, that's absolutely close to our heart. That's what we do. So I'm always learning. I like to see how new technology can deliver services to those who do jobs I used to do. I'm often not the smartest guy in the room. I'm definitely not the smartest guy on the panel. So I'm going to briefly introduce the panel as we go sort of your left to your right. I'll briefly introduce them, and then we're going to go through some sort of discussion points. So first of all, Geoffroy Beaudot. He is the local resident on the panel. He's the head of space department for the Defence Directorate here in Luxembourg, so ideal to be our first speaker. He works across European defence, the Commission, and with NATO in policy and programme roles. And he was previously in the Belgian Army. I recognised his face from many moons ago, so we've probably been at the same conferences. And he's worked in military acquisition roles. We've then got Alvaro Sanchez, who's safe and secure, and we're glad to see him back. He is the CEO of Integrasys, where he's worked for 10 years. They work in network automation, do R&D and support defence solutions. And before that, he was a nuclear research engineer at CERN. So that's seriously clever stuff. And they've just opened their 10th office here in Luxembourg, and he seems to spend most of his time travelling between his various offices. Eric Kimery, who is the J63 planner. So that's a communications operation branch for those that don't do the numbers of defence in US European Command. So he's got a very wide remit across a significantly busy part of the world, both for US and NATO interests. Eric's had over 30 years in the US DoD, working various SATCOM programs, and here in Europe works closely with Intelsat and GovSat in delivering solutions as he looks to expand capabilities for UCOM. Finally, Nitin Bhat, who's the SVP of Engineering at SES Space and Defence, provides a great deal of ComSat services to the US DoD. So Nitin's going to pick up all Eric's questions later on. Nitin's also had over 30 years' experience designing and implementing defence networks, and again, placed for this panel. So before we dive in, and noting it's sort of getting late to the day and you need time to think about your questions, a few themes that just may come out. Some may be picking up on earlier sessions from the UKMOD, the industry speakers who've talked about zero trust architectures, previous panels on cyber, and of course on multi-orbit domains, which was an excellent panel. We've got about 25 minutes. I think there's a clock there. It's big and red. We have 23 minutes, 43 seconds. So we could go into lessons from Ukraine. We could go into the challenge of contested orbits. We'll probably talk about the space segment, the ground segment, the user segment, where the threats are, where the attack vectors are, et cetera, et cetera. I think it's important to note, and I say this both having run Skynet 5 Milsat, but also now working for a ComSat company, that it's one big architecture, it's one big network. You know, ComSat is not the fallback to Milsat, which I think in my youth was what I understood to be. So it's not just bringing extra capacity, it's bringing extra resilience, it's bringing extra choice, and it's presenting an aggressor with a serious different calculus. So targeting a military satellite is a very different risk calculus from targeting commercial SATCOM, so we'll probably get into some of that. And people have mentioned the PACE plan, the primary, alternate, contingent, emergency, whether you do that switching between networks or whether they're always on, that again is part of the security architecture. So I'm going to go through each of the panelists in turn. to talk about what they do, what they think about vulnerabilities and how they may address them. And then I'll come to the audience for some questions. And if not, I've got some last-minuters, which I've scribbled down earlier. So we're going to go into the panel now, and Geoffroy is going to talk about your views on security and how to protect the architecture.
Yes, let's do it. So I think we have many solutions for protecting SATCOM. The first, but before going in the different approach, I think we need to know what is in space. We need to understand. So the space domain awareness is, from my point of view, the starting point. You need to know what is in space, characterizing the asset, knowing exactly which are the risks for the different satellites. Then you have to use secure system. You have different options. GovSat is one of them. You have to protect your system with anti-jamming system, and keeping in mind that if you are interfered by something, you need to know where is this interference. So a good geolocation system is also something important, and to know from where comes this interference. Then, from my point of view, it's a buzzword, but resilience is definitely key. Once again, it's a buzzword today, and or do we bring resilience in space? It's just by accessing to different orbits, different systems. And what we do in Luxembourg is leveraging A3B Empower using this MEO constellation with the project we call MGS, MEO Global Services. And by providing resilience and accessing to multi-orbit, we are for sure protecting our satellite communication system. Last but not least, the ground. Of course, we also have to protect your ground system with cyber against a cyber attack. You also can use anchor station sharing with partners, with allied nations. That's exactly what we did in Luxembourg with Belgium and Netherlands. We are interconnecting our anchor stations, so if we have an issue here in Luxembourg, we can rely on our alliance. Of course, EPW, European Protected Waveform, or in the US, the Protected Tactical Waveform are also key to protect your communication from the ground to the satellite. And last, and then I will, of course, leave the word for my colleagues, but can you reach all this ambition? Once again, a new buzzword today, partnership, allied by design. You can do it bilateral, multilateral, using NSPA for the partnership, using Europe. We also have inside of the EA some ways or means to cooperate, and from my point of view, that's the key if you want to protect your SATCOM, work together.
So I love the fact that your first point was around understanding the domain and shared situational awareness, which was my get-out-of-jail-free question at the end. So that's brilliant. So thank you. On to Alvaro.
So I fully agree on working together. So we see how more and more threats are coming. We saw a presentation before between where I am. So I was not finding the room after the restroom. Apparently I was sitting there, but I was not in the right position or time. So this is very important. Also, the design is very important. So having a secure connectivity from designing secure networks. So starting with the design, then moving to the management, understanding your enterprise, understanding how many assets do I have, which are my most vulnerable assets, and also understanding what are the threats to those assets, and having alternative backups. Also moving to anti-jamming and geolocation. As Geoffroy mentioned, those are very capable tools, but also they are one tool of the toolbox. You also have alternative paths, multi-orbit. So leveraging all these different assets, but also security TNC. So if there is something to collide with, you can avoid, as well as tracking objects in space, characterizing those objects, or characterizing objects in the ground. So again, it needs to be very secure. The more connectivity paths you have, the greater options you can make sure that the network is secure. But also monitoring very well the remote assets that are typically the weaker link, for example, for cybersecurity. So we need to monitor and analyze and orchestrate and maintain all the enterprise, all the assets that we own and we operate within our network. And this only can be done with AI. So artificial intelligence allows significantly on improving what it has been with Excel's enhanced and brains over many years. But again, as the complexity in networks grows as the network grows, but also exponentially with the new orbits, this needs to be completely automated. It needs to be driven by an AI machine that helps on mitigating all those threats and also interconnect within each other. So to have the design interconnected with the anti-jamming, the geolocation interconnected with the threats mitigation, and also with Earth observation tools to understand, okay, I'm being interfered by here. Where is it and how it looks like? So things of that nature of full automation, as well as if I'm being jammed anywhere, to be able to react very well. So find the stage when you are required.
And what Integrasys do, correct me if I'm wrong, is manage that. So that's a really wicked problem set. You know, it's different commercial companies, different technical solutions, different architectures. You do quite a lot of that sort of sensing around the terminals and the architecture. Is that kind of where you're aiming at?
So we do a portal that is an enterprise management and control that goes from the design, manage, monitor, geolocate, anti-jam, and do certain layers. We have more than 20 plus products, all interconnected, and manage all the equipment like satellite payloads or networks in the ground. So that interaction with multi-vendor domain brings a huge strength as well as multi-orbit domain, because it simplifies to manage any network and make it much more secure, so and robust to threats.
Yeah, so we've picked up sort of understanding the domain and what's going on in space and perhaps threats from aggressors, but you're actually understanding the system and the network in great detail. So that's another stage, which is great. Okay, thanks. So we're going to move on to Eric now, who's got a sort of UCOM and DoD perspective.
Okay, good afternoon, good evening, everyone. Really quickly, I wanted to thank everyone, the GovSatCom conference personnel, for inviting me and setting this up. This is a fantastic venue. I really appreciate that. The other point I wanted to make is for all the people who are speaking English as a second language, thank you, because I wouldn't know anything else. So, but I really appreciate that, because I've lived in Germany for about 15 years, and I still struggle with, I guess, Ein Bier bitte is about all I've learned. So, yeah, so as Neil said, I'm a 30-year DoD, US DoD, government civilian. Satellite communications has been my focus. At the COCOM level, right, combatant command level, within the J6, it's a communications directorate. What we're focused on primarily is influencing capabilities that are coming into theater, all right? With the stand-up of Space Force and US Space Com, we found unique opportunities to partner with them, to let them know what we see is coming from a theater perspective. We also have, and we haven't had it in the past, but we very recently have some funding for ComSatCom. And so what we've been trying to do is partner with industry. While we're working with Space Force, we are enabling the theater in pockets of capability, right, in hopes that US Space Force can then come in later and leverage that technology or that capability and build upon it. So that's one thing that we're really focused on inside the J6 is to enable the theater with ComSatCom. Because I wanted to make the point that technology today around the globe, it's just proliferated. So we're to the point there is not one single satellite communications system solution that is going to provide us a persistent C2 capability on the battlefield when we need it. So that's just driving us to all the things that we've learned, I've been listening about today, right? Pace, multi-orbital, lots of capabilities. There's a fantastic point about leveraging AI that's important too, because I was just trying to think of, from my old mill SATCOM days, very process-oriented, not fast to move, not quick to adjust. And how would we do that in the battlefield if we're going to try and utilize LEO, MEO, GEO capabilities on the fly? So I just wanted to, most of my experience is mill SATCOM. We're purpose-built, right? Very rigid in that process. Type 1 encryption, we have TransSec, we have ComSec. But as we start to partner more and more with industry, international partners, and we build that capacity in theater, we're trying to diversify our, for instance, RF head locations, right? We don't need just 4, we'd like to have 8 or 10 or 12. We'd like to take advantage of existing infrastructure that's there in theater already. We might not be using it, but we can bring capability to it. And so those are the things we're looking for to try and partner with industry and international partners. What my blind spot is, and it goes to really what we're talking about here. I don't know how commercial industry sets the standards to provide that secure architecture. I know from a DoD perspective we have our processes, but from an industry standpoint I don't know necessarily. And so I've been hearing stuff today a little bit more, and I think that's part of what the challenge of our panel was, because I'm basically a consumer of what you're bringing, as opposed to how am I enabling protected architecture.
So thanks, Eric. I think that's a great segue into Nitin to talk about that architecture. I think we've got a slide for you to go through.
I have my pen and paper ready. I thought Eric was going to ask a lot of questions.
Yeah, they'll come. But we're going to leave this slide up for the questions as well, because it's quite a good reference point to go to.
Yeah,
so.
thanks for having me. As one of the largest end-to-end solution providers for the US DoD, I would love to provide my perspectives here. See the slide, it highlights some of the important security considerations for space, network, and terminal layer. Apologize, it's a bit busy slide with a lot of acronyms. I was trying to fit everything into one slide. One of the things I want to start off is a solution is always a balance between cost and risk. And one way to quantify risk is risk management framework. And risk management framework has 3 impact levels: low, moderate, and high. And it ties that to CIA, or confidentiality, integrity, and availability. Some of the things you see here on the slide, like FedRAMP, Certified Terrestrial Networks, IA-PRE, CAIQ, CMMC, they all use RMF NIST controls. Outside of that, I wanted to hit upon a couple from each of these layers and share it with the group here. Hopefully, that should answer some of the questions that the audience has, and looking forward to more questions. So on the space layer, I wanted to touch upon beamforming, because beamforming helps you track a terminal as it moves, so there is no energy spillage from a protection standpoint. And the other one I wanted to hit upon, and also the beamforming actually helps in mitigating interference, as it can null out interference in many cases. The other one I wanted to hit upon is OISL. It was touched upon earlier in the other panel about optical intersatellite links. I know the Star Shield, upcoming Kuiper, second generation OneWeb, Lightspeed, and the future MEO constellations would have this capability, which allows you to carry data from one part of the globe to the other part of the globe without touching the ground. I know, Francois, I think you already hit upon geo interference and location as an important consideration for that. On the network layer, I have STIG is something I thought would be interesting. as the government person, I think you would appreciate that. When you have a waveform or data that you need to transport, independent of whether it's virtualized or not, you want to make sure the appliance is locked down from a cyber perspective. And STIG, or the Security Technical Implementation Guide, helps you do that. I know Alvaro touched upon EM&C. I think that's an important piece because as a partner, we have our own EM&C system to do a secure end-to-end SLA management and also provide transparency to our customers. What's important is the way things are going, you have thousands and thousands of data points being collected, so huge amounts of data. So I think from a security standpoint, it's important that we have things which is FedRAMP certified, it's in the Gov Cloud with the right impact levels so you can maintain the security posture. The last one, a couple of them touch upon is on the terminal layer. I think, Eric, you already talked about TransEC and encryption. But one thing I did not hear a whole lot today was open architecture. And that's what allows you, I feel, to implement TransEC, FIPS, encryption, and also hide in the noise with LPX. And lastly, I think one thing that is every panel touched upon is hybrid architecture. I think hybrid architecture helps with the pace plan. And so you can move from one frequency band to the other, or one orbit to the other, or one constellation to the other. Those were the initial thoughts here. Thanks.
No, that's brilliant. Thank you. I think this is one of these kind of 1 minute or 1 hour slides. It can kind of do both, but I think you've actually got through almost every abbreviation on there. I guess I'll make an observation, and people can start thinking about questions, which is to do with attack vectors. As we've seen, defense become more fragmented, smaller teams, uncrewed platforms, these kind of places. There's more and more things connected to a quite complicated space network. So every time we put a terminal out on the ground, there's another, attack vector in. So I guess we've now got a more complex ecosystem that's going further down the chain of command than it ever did to people who are, right near the front line, backing up against, electronic warfare assets from the Russians or whoever our future aggressor will be. So it's becoming a more complex domain.
Absolutely, yes. So we have good work in Ukraine where we're providing systems for both denying and anti-denying, so anti-jamming. They are becoming more and more popular. And the reason behind is that people, so one of the reasons is that even the regional governments within the Ukraine, they can actually buy equipment for jamming because it's the only way they have in law to protect themselves. So this is very, very important. So yes, even their own troops, they receive their own attacks. So to have the measure and the countermeasure and understand what are the margins between those, it's critically important. Also, when you are looking at special forces, when you are looking at fast deployments, simplicity is key. Because the comms guy maybe is the youngster that used to be a YouTuber before, and now it's providing the comms, and they don't have any clue of comms. And this is a big challenge. So the easier you do the systems to utilize, the less human factor. And I was hearing today that the worst nightmare of this industry is the human factor. So it is true. Satellite hasn't been easy. And Starlink made it very easy. But also, it needs to be very reliable. It needs to have SLAs. It needs to be 4 nines, not as best effort. With high capacity, with high redundancy, and multipath. So one of the things is, what happens is this path fails, even its power. Because sometimes it's power when it fails, or it's jam or whatever. What is your second channel to communicate, or how can we recover superiority? Many times we are seeing how important that spectrum superiority is. You communicate and the adversary cannot. This is extremely important because it's information superiority and you increase the situational awareness. And you only know when you have lost the superiority in the situational awareness when you actually regain it. So all that intelligence needs to come in hand for the user in an easy-to-use manner. Otherwise, it's useless.
Yeah, I mean, so they're great points. I'll pick up one. So 70% of the outages on my final Afghan tour were power and air conditioning, and most of the jamming was unintentional from allies. So we've as a sort of NATO, we've had 20 years trogging around the desert without an aggressor. Is there any? I mean, Eric, you're nodding. Is there anything you're able to talk about in this forum from some of what's been going down in your part of the world?
Well, so it's just to dovetail with you, because I think from a DoD perspective, we played a U.S. DoD perspective. We were playing in an uncontested environment for so long, and we just, quite frankly, got comfortable operating that way. Okay, AISR is an example. We did not modernize the platform, and we're paying the price a little bit for that now. I think it's a good point to understand. You know, some of the experiences that I'm hearing, people coming back, even just going out to the field and training in Grafenwehr. They love Starlink. They don't want their purpose-built MIL-SATCOM capabilities that takes generators and 5 people when they just need they need no SATCOM experience or expertise. They need a IP technician and they're up in minutes, as opposed to worrying about they're on day 3 of bringing up a MIL-SATCOM built system that's still not up, and you know, the S3 officer in charge there is wondering if he's going to get fired or not. So technology is fantastic. You guys are bringing it there. Just understand that all the complications you have to take on, because I think out in the battlefield, for instance, as an example, there's a person out there trying to just send back images of a place, right? We talk about how am I going to do multi-orbit. Well, if he or she has to do 4 or 5 different things, then he probably didn't get those images up in time. It's got to be kind of a self-healing kind of network. The operator doesn't even probably know they're being jammed necessarily or have an EMI problem. It's just up in space, something AI related probably decided, hey, we need to auto switch to something else.
Awesome. So that clock literally says 0, 0, 0. Does that mean I'm allowed to get a final point from everyone on the panel or not? Okay, so sorry for no questions, but we've had quite an interesting discussion. So I'll start at the end and go.
No, I think we're
was
done.
That a yes?
She said one minute. Oh, okay.
Okay, so have you got, what's the best thing defense could do?
No, I can add to what Eric just said. I mean, 3 things which were touched upon in the panels today, which I think would help. Zero trust architecture was briefly touched upon. It's not prevalent yet, but I think it's going to be. We talked about cloud. I think cloud usage is going to increase, which is going to help. And finally, I think virtualization is another piece, which I think eventually will help with the security
awesome,
side.
Thanks, mate. Eric, you got any little killer? Yeah. You were good. You were great. Got final points. What's that? Alvaro now? AI?
Make it easy. If you make it easy, it will work. If you make it harder, it won't work. Whether it's MILSAT, COMSAT, GOVSAT, or whatever.
Make it easy. Awesome. Geoffroy?
Come in Luxembourg.
Awesome. Okay, I'd like to thank the panel. Sorry, we're a minute over.
I did have one alibi. Was also so I'm not sure that everybody in the audience knows. Right, we have about 200 megahertz of MIL-Ka bandwidth on GovSat-1, and so we are partnering that way for sure. And into the future, we're trying to build into Beetsdorf and a couple other RF locations, commercial teleports. So for a little perspective, it's not just words, that's what we're trying to get after.
Okay, we're going to walk and talk. So we're bridging between multi-orbit and terminals and modems, all of which have a security element. So I'd like to thank the panel, bags of experience, and we'll get off the stage.